Number 1, graph the functions f of x equals 4 to the x minus 7 and h of x equals negative x squared minus 4x plus 4, and state the values of x such that f of x equals g of x. So the first thing we're going to have to do is graph both of these functions. So to graph these functions, the easiest way we're going to do it is go to our calculator. If you go to y1, type in that first function of 4 to the x minus 7. Make sure that minus 7 is not in the exponent. Go look at a table. I can't plot the point 357, but I can plot 2, 9. So I'm going to plot the point 2, 9, 1, negative 3, 1, negative 3, 0, negative 6. I have a y-intercept of negative 6, negative 6. And then we notice our y values begin to approach negative 7. And it makes sense that our y values begin to approach negative 7 because that's what that downward shift is. Normally they have horizontal exponential functions have asymptotes of the line y equals 0, the x-axis. So if I shift it down 7, my new horizontal asymptote is going to be y equals negative 7. Because it's 4 to the x, this exponential function grows very, very quickly. So there's one function there. And here's h. H of x equals negative x squared minus 4x plus 4. So let me go put that in y2. Negative x squared minus 4x plus 4. We can look at the graph of these. Very nice. And we go look at the table to plot that quadratic there. The turning point is at negative 2, 8, because that's where the table begins to repeat itself again. So let's go from negative 6, negative 8. Negative 6, negative 8. What color am I going to use for this? Red. Negative 6, 1, 2, 3, 4, 5, 6. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I should keep my exponential function going there. It keeps getting closer and closer to the line y equals negative 7. Doesn't touch it because it's the asymptote, but it gets closer to it. Negative 5, negative 1. Negative 5, negative 1. Negative 4, 4. Negative 4, 4. Negative 3, 7. Negative 2, 8. And then it's a quadratic, so it has that symmetry everywhere. Has that symmetry that I'm just going to copy to get the overall shape here of the parabola. So that's my function h of x. I should label them. Green is f of x. Have to label them because I graphed two functions. So now I want to state the values of x for which f of x equals g of x. So f of x equals g of x twice here because it's where they intersect. They intersect twice, but I only care about the x values. So how am I going to find these x values? Well, they're not nice integers, so I'm going to have to use the intersect button. So second trace intersect, move the cursor, move Mr. Blinky closer to the intersection point, and hit enter 3 times. So the first value, did I say what to round to? To the nearest tenth. The first value is 1.16, which rounds up to 1.2. So we get x equals 1.2 is approximately that intersection point. And the second intersection point, second trace intersect, scroll all the way over, scroll the cursor all the way over. You can just hold it down, I can't on the computer. Close enough. Hit enter 3 times. And it tells you that intersection point of negative 5 point round up to 9, negative 5.9. So this happens at about negative 5.9. We only care about the x values when they ask us when does f of x equal f of x equals h of x in this case. If I want to know What solves that equation? What's a value of x that solves that equation? It's the x values of their coordinates of intersection. Number 2, state the values of x such that 2 times the absolute value of x plus 1 minus 2 equals 9 to the negative 1/2 x minus 2 plus 1 to the nearest hundredth. So this is a bizarre equation. I have an absolute value function equals an exponential function. Hopefully you recognize that you're going to plug this into your calculator and y1 equals y2. So let's go do that. Let's go plug f of x as first function into y1, g of x our second function into y2. So clear those out. The first function I have here is 2 absolute value of x plus 1, 2 math over to absolute value of x plus 1 minus 2. Let's just double check that I did that right. Yes. And then the second function is 9 to the negative 1/2 x minus 2, negative 1/2 x minus 2 plus 1. So I just typed each function, each side of the equation into a different function on my calculator. Hey, graph to see how they look. There's the absolute value function. There's the exponential function. So it happens 3 times. There are 3 values of x that satisfy that equation. So second trace intersect. Move the blinky, Mr. Blinky, close to the intersection point. Hit it 3 times. So to the nearest hundredth, we have x equals, we only care about the x value for here, 0.50, because I'm going to not round up, so 0.50. And we repeat, second trace intersect, scroll over to the next intersection point, enter 3 times, negative 2.60, nope, negative 2.6, look at the next one that says round up, so negative 2.61, so I'm going to round up there. And finally, one more, second trace intersect. Second trace intersect. I'm going to scroll on over to that last intersection point and get negative 5.69, because I'm going to round up there because of that 5. So x equals negative 5.69. Those are the 3 values of x that satisfy that equation, because I plugged it into y1 and y2 and found where they intersected, found the x values of where they intersected. Number 3, given the function h of x and k of x, find the values of x such that h of x equals k of x. So whenever you're seeing when are these 2 random functions, when does that absolute value equal the quadratic, we're going to use that strategy of plugging it into the calculator and seeing where they intersect. So I'm going to do absolute value of x minus 4, absolute value of x minus 4, plus 1, not 44, plus 1, just a 1 plus is fine, and then x squared plus 3. And we're going to look at the graph. There's the absolute value function, there's the quadratic. To see where they intersect, I just do second trace intersect, move him close to one intersection point, enter 3 times. So that's a nice integer point there, x equals 1. So when does h of x equals k of x? We have x equals 1. You might see that written as h of 1 equals k of 1, because 1 makes those 2 functions equal. They both equal 4. And second trace intersect, second trace intersect. Move the blinky guy, Mr. Blinky, over to the second intersection point. Keep on going. That should be close enough. And you get x equals negative 2. You get x equals negative 2. So those are the 2 values of x that satisfy this equation. There's no real way to there is a way to do it, but it's a mess. To algebraically solve this, the tools are pretty limited. This works very, very nicely to plug this one into y1 that function into y2 and see where they intersect. Number 4, which of the following values of x to the nearest thousandth is not a solution to the equation f of x equals g of x? So which of these is not a solution? Where that's f and that's g. So I want to know, when does 1/3 to the x equal x cubed plus 3x squared minus 2x? Because that's f of x equals g of x. F equals g. Well, this is a bizarre equation. An exponential equals a polynomial. There's no algebraic tools to do this, so we're going to have to solve this graphically and approximate it. So we're going to go to our calculator and plug both of these in. Plug f into y1 and g into y2. So 1/3 to the x, 1/3 to the x, and I guess I'm going to use 2 and 3. Doesn't matter which ones you use. X to the third plus 3x squared plus x minus 2x. And I'm going to graph them to see where they intersect. There's the exponential function. There's the cubic polynomial. It's next to the third, so it should look like that. And I see that it intersects it 3 times. Well, what are those intersection points? Let's move Mr. Blinky close to one of them. Negative 0.545. X equals negative 0.545. That one works. I want which one is not. So that one is approximately a solution, so we cross it off. And we rinse and repeat. Second trace intersect. Second trace intersect. Move Mr. Blinky close to the next intersection point. Hit enter 3 times. Negative 1.851. Negative 1.851. So choice 1 gets thrown out because they intersect there. Okay, now we need to see this last one. Second trace intersect. Move Mr. Blinky close to the other one. Let me get it pretty close. 1, 2, 3. 0.712. 0.712 is a solution. So we get rid of that one. Choice 3, 1.32 is not a solution. 1.32 is not a solution to this equation. Only these 3 values are, so choice 3 is the answer. Had to be careful because they said which is not a solution. Is this hard? No, it just takes time to recognize I can't solve this algebraically. I have to use my calculator. Number 5, solve the following equations for x to the nearest hundredth. So the nearest hundredth means 2 places. 5 equals 4 to the x. Well, if this was like 16 equals 4 to the x, we'd be able to use common bases. But I can't make 4 and 5 have the same base. So we're going to plug 5 into y1, 4 to the x into y2. Clear out these old functions. I'm going to have 5 equals 4 to the x. Graph. There's 5. They intersect once. Second trace intersect. So the value of x that solves that equation is about 1.16. About x equals, pink, x equals 1.16, because I went to the nearest hundredth, which is 2 places. And looking at the third, I'm not going to round up, I'm going to leave it alone. So that's the approximate answer. And that makes sense, because 4 to the 1 is 4, and 4 squared is 16. So an answer of x equals 1.16 makes sense, because that's 5 is in between 4 and 16. So that makes pretty sense that we got that x value. And finally, 2 to the negative x squared plus 2 equals 3. Again, I can't get common bases. If that was a 4, an 8, a 1 over 16, I'd be able to use common bases, but 2 and 3 aren't related, so I'm going to have to plug this into y1 and 3 into y2. So, in y1, or really in any y, 2 raised to the negative x squared plus 2 equals 3. So let's look at a graph of this. That's a bizarre function. Okay, they intersect twice, so there's 2 solutions here. Second trace intersect. Enter, enter, enter. 0.64. You get x equals 0.64. That's an approximate solution. And second trace intersect. Move it over. Negative 0.64. So x equals negative 0.64. And this is completely unrelated, but that blue function is an even function because it's symmetric across the y-axis. So it makes sense that they both have the same y value of 3 at the opposite x values. So if you notice that that blue function was even, it would make sense that it had that symmetry. But did you really have to recognize that? No. Most people wouldn't. Only people like me would. But those are my 2 solutions. So we can solve any equation we ever want to by using this method of using the intersect command on our calculator.